All right, welcome back to Cognitive Psychology. This is week 15, class number 1, where we're going to continue our look at chapter 13, Judgments, Decisions, and Reasoning. So thank you for joining me. And what we're going to do today is we are going to continue on with what we left off last time, which was taking a look at logic, taking a look at human reasoning. And specifically, we're going to dive in deeper today into the descriptive side of reasoning, where we take a look at how humans actually handle conditional syllogisms. So if you haven't already watched the week 14 class number 2 video, highly recommend you take a look at that one before you begin this one. And if you're a little bit shady on what you saw last time, maybe even rewatch that video before moving forward. So what we're going to do today is we are going to have a very quick recap of human reasoning, specifically focusing on the difference between normative and descriptive reasoning. Then we're going to have a really quick recap on deductive reasoning, followed by a really quick recap on conditional syllogisms. And all of that is getting us ready to tackle our new material for today, which is going to be the Wason selection task. That's your Coglab number 12. And what the Wason selection task will do is it will measure the descriptive reasoning of how humans reason with conditional syllogisms, so we can compare that to the normative reasoning of conditional syllogisms. So we just used the terms normative versus descriptive reasoning. That's where we're going to start our recap, because that's a very important distinction that we must be very clear on. So when you're studying human reasoning, you distinguish between the normative reasoning and the descriptive reasoning. So normative reasoning, that is how humans should reason. That's kind of the ideal of what we should be doing. And then descriptive reasoning is what we actually do. How do we actually reason? So normative reasoning is what is the correct thing to do. Descriptive reasoning is what do we actually do? So to discover what normative reasoning is, that we turn to philosophy to find out, that we look to logic to determine, that we look to mathematics, computer programming, artificial intelligence, all those types of analytical tools that can tell us what the correct answer is. What is the right way to reason? What is a logical way to reason? Basically, what is the correct answer when we're faced with a reasoning problem? On the other hand, descriptive reasoning is what we actually do. And this is just based on our behaviors. This is just based on putting humans in situations and us as psychologists measuring what they do in those situations so that we can have that description, hence the descriptive reasoning. We can have that description of what they actually do. So descriptive reasoning, you can think of it as nothing more than a list of behaviors of what humans actually do. And oftentimes, because we're trying to get to because we're trying to get insight into how the mind represents reasoning, we're trying to get insight into the strategies that our minds use for reasoning. Oftentimes, you'll find that psychologists will set up very difficult reasoning tasks because they're trying to induce errors. They're trying to make humans or force humans into making errors, because oftentimes the difference between normative and descriptive reasoning is most easily seen during errors, right? It's more easily noticed what the differences between descriptive and normative reasoning are if we're making errors. And then it's our job as cognitive psychologists to take a look at those errors and infer what is going on. What is going on in our mind that would cause us to make those errors? If we're not doing perfect reasoning, if we're not doing that normative reasoning, then what is actually going on in our minds? And that's what we want to do in order to understand human behavior. So the normative reasoning, it's great to know that. It's great to know what we're supposed to be doing. But as a psychologist, personally, for me, it's way more interesting to go to the descriptive reasoning and figure out what we are actually doing. And the theories that we build are helped by understanding the normative reasoning. Where should we be? And then using that to compare to the descriptive reasoning, so that we can come up with theories, we can come up with strategies, we can come up with ideas about how we represent things, so we can truly understand how humans actually reason. So in terms of reasoning, we're going to, again, distinguish between two kind of flip sides of reasoning, deductive and inductive reasoning. So deductive reasoning, that's where you reason from general to particulars. And this one is used in science a lot when you start with a theory and you end up with a prediction. So you could have a very general statement, such as all swans are white. This is a theory about swans, right? This is saying that, you know what, all swans are white. That's a generality. Add a second proposition to this, that a particular bird is a swan, and given deductive reasoning, you can conclude that that bird is white. Because if it is true that all swans are white, and if it is true that this bird is a swan, then you can reason deductively and conclude that that bird is white. So that's one part of reasoning that is oftentimes used in science. Both of these are used in human life all the time, but deductive reasoning has its place in science. It's one half of the reasoning chain for science. Inductive reasoning is the other half, because inductive reasoning goes the opposite way. It reasons from a particular to a general statement. So if I was a biologist and nobody had ever seen swans before, and I came across a bird, and I go, oh my gosh, this is a bird, I'm going to call it a swan. And guess what? This first swan that I've ever seen is white. I might induce from that particular the general theory that all swans are white. Now, you'll notice that this is pretty weak because I found one swan that is white, and from that I extrapolated and induced the theory that all swans are white. So this was chosen in particular to show one of the big differences between deductive and inductive reasoning, and that is that deductive reasoning can give you definite conclusions. If the premises are true and you go through a deductive reasoning chain, the conclusion is guaranteed. So if all swans are white is true, and the particular bird is a swan is true, we can guarantee that that bird is going to be white. That's a definite conclusion. On the other hand, inductive reasoning only ever gives us probable conclusions. So if we find one swan that is white, we might induce that all swans are white. That's not highly likely. But if we found our first 100 swans to be white, then the conclusion that all swans are white becomes even more likely. And if we found our first 1,000 swans that are white, the conclusion that all swans are white becomes even more likely. But notice that it never becomes definite. It never becomes 100% guaranteed, because all that it takes is that one black swan, that one non-white swan, and our conclusion is false. So inductive reasoning gives us probable conclusions. Deductive reasoning gives us definite conclusions. And that's one of the reasons why when we started this look at human reasoning, we looked at deductive reasoning, because deductive reasoning has definite conclusions, which means that the normative reasoning portion of deductive reasoning, that portion where we analyze what should we do, is much more clear for deductive reasoning. It's much more clear what the correct answer is for deductive reasoning. So it's a great place to start our look at human reasoning. So deductive reasoning, it can be either classified as valid or invalid. So this is two sort of categories of deductive reasoning. As we're going to see, the valid category, that's normative reasoning. And then the valid and invalid category could be descriptive reasoning. So valid reasoning, valid deductive arguments, these are arguments where the conclusion follows logically from the premises. That means that you follow a logical chain of reasoning from the premises, and your conclusion is a result of that logical chain. Invalid reasoning or invalid arguments are where the conclusion does not follow logically from its premises. Now, it might help us to think about this in a different way, and that way is this. The valid arguments have the characteristic that if the premises are true, then the conclusion must be true. So if you accept the premises as true, that locks in the conclusion. The conclusion is guaranteed. It's 100% going to happen. You can argue with whether the premises are true or not, but that goes outside of the realm of deduction. So as we mentioned last time, to track a deductive reasoning argument, you have to assume that the premises are true. So that's the first move. Assume the premises are true. And then if the premises are true and the conclusion must be true, there's no way for the conclusion to be false, you're dealing with a valid argument. An invalid argument, on the other hand, has the characteristics where if the premises are true, then the conclusion could be true or it could be false. An invalid argument does not lock in that guaranteed conclusion, and that's what makes it invalid. That's why it's classified as invalid. So for a valid argument, if the premises are true, conclusion is locked in. It has to be true. In an invalid argument, if the premises are true, the conclusion might be true, but it might also be false. That is, it's not locked in. And then we applied this to our analysis of conditional syllogisms. And conditional syllogisms, they're arguments that use the statements, they use the conditional syllogisms of the form, if P then Q. So these are statements and ways of reasoning that we use all the time to try to explain the world, to try to explain cause and effect, to try to explain the relationship between two different things. So examples of these would be something like, if you study, then you will get a good grade. You study is the P portion of it. You will get a good grade is the Q portion of it. And it's a very good practice to start identifying what is the P portion and what is the Q portion. So if you get a job, then you will buy a house. You get a job is the P portion. You will buy a house is the Q portion. If you take row 23, then you will get to the freeway. You take row 23, the P portion, you will get to the freeway, the Q portion. A particularly important one for scientists and us psychologists, if theory X is true, then prediction Y should occur. Theory X is true is the P portion, prediction Y should occur is the Q portion. So that if portion, that P portion that I kept calling it, the fancy name for that is the antecedent. The Q portion, or the then part of the argument, the fancy name for that is the consequent. So now that we have the if P then Q conditional syllogisms, we can start forming arguments that use that statement, and these are these conditional syllogism arguments. And as it turns out, there's four types of arguments that are the four types that are typically made with these. Two of them are valid, two of them are invalid. So we're going to start with the valid conditional arguments. And because these are valid arguments, these arguments are part of normative reasoning. This is the way that we should reason using if P then Q statements. This is what we should do. These are the logical arguments that we have using these conditional syllogisms. So the first one is affirming the antecedent. And that's known by its famous or its more fancy Latin phrase, modus ponens. And the structure of this argument is as follows. Premise number one, if P then Q. Premise number two, P is true. So remember that P is the antecedent. We're saying that P is true. This is where this argument gets its name. So affirming the antecedent is literally saying, affirming the P portion, that is saying that P is true. And hence these conditional syllogism arguments that we're going to take a look at, if it helps to understand how they're named, they're always named for the second premise. The first premise is always if P then Q. And the second premise is where each of these arguments gets its name. So in this case, we're affirming the antecedent. So premise number two is that P is true. Now, if premise number one is true and premise number two is true, then we are guaranteed 100% that Q is true. So this is the abstract version of this argument. Let's put a little context on it. So premise number one, if you study, then you will get a good grade. Now, if you're a critical thinker, you have probably already objected in your mind to premise number one. You have probably already thought to yourself, whoa. There's so many examples of where you can study and you don't get a good grade. Like maybe you study and the exam was just way too difficult. Maybe you study, but you studied the wrong thing. Maybe you studied, but then you didn't get a good night's sleep. There's so many ways that premise number one could be false. And that's true. And that's a good way to think about it if we were doing critical thinking. But what we're doing right now is we're doing logic. And for logic, you have to assume that the premises are true. When you're analyzing a logical argument, you have to assume that the premises are true. Otherwise, you can't even start. So at this point, we're just going to assume, we're just going to take it for granted that premise number one and premise number two are true. And we're going to see where that leads us in this argument. And then once we're done analyzing it, then you can start attacking the premises as whether or not you want to accept them. But for the present time, we need to accept these premises as true. So let's turn off our critical thinking brains. Let's turn on our logical thinking brains and take a look at this argument here. So if you study, then you will get a good grade. Premise number 2, you study. If both those premises are true, you are guaranteed that you will get a good grade. You're guaranteed that the conclusion will occur. So visually here, let's take a look. If it is true that if you study, you will get a good grade, and you studied, that law then requires that you get a good grade. There's nothing else that could happen, and that's what makes this a valid argument. If the premises are true, the conclusion that you get a good grade has to be true. All right, next one that's valid, denying the consequent. This is also known by the more fancy Latin modus tollens. So this is denying the consequent. Remember, that's what's going to happen in premise number 2. So premise number 1, we start off if P then Q. That's the one that we always start off with. Now we're going to deny the consequent. The consequent is the Q portion. We're going to deny it. We're going to say Q is false. If premise number 1 is true and premise number 2 is true, that Q is false is true. And that might get a little bit difficult to kind of follow. So make sure that you are tracking before you move forward. But if premise number 1 is true and premise number 2 is true, then we are guaranteed that P is false as well. We are guaranteed that P did not occur. So that's the abstract version. Let's put some context on it. Premise number 1, if you study, then you will get a good grade. Premise number 2, you did not get a good grade. If those two premises are true, then it is guaranteed that the conclusion was you did not study. Because the rule is, if you study, then you will get a good grade. You did not get a good grade. That means that you couldn't have studied, because if you studied, you would have gotten that good grade. So something else must have happened. You must have not studied, because that's the only way that you would get a poor grade. So that again locks in that conclusion. Those two premises, if true, locks in the conclusion, and that's what makes this a valid argument. So we saw affirming the antecedent, denying the consequent. Both of those are valid arguments. Both of those are part of normative reasoning, the way that we should reason, the correct logical way to reason. Now let's take a look at 2 ways of using these arguments that are outside of normative reasoning, because they are invalid arguments, right? They're not the way that we should be arguing or reasoning, but they're included here because they might be the way that we actually reason. These 2 arguments might be part of our descriptive reasoning mechanisms. So let's take a look at these 2, and you can kind of ask yourself and self-reflect, have you ever made these invalid arguments yourself? Have you ever made these errors on your own? And chances are, if you're human, the answer is yes. So let's take a look at what these answers are, these invalid arguments are. So first we have affirming the consequent. And one thing that you'll notice is that these invalid conditional arguments, they don't get the fancy Latin names. Fancy Latin names are only for the valid arguments. So this is affirming the consequent. Again, that's what's going to happen in premise number 2. So premise number 1 always starts off if P then Q. Premise number 2, we're going to affirm the consequent. We're going to say that Q is true. So if P then Q, if premise number 1 is true and premise number 2 is true, then we as humans might be very tempted to say, you know what? The conclusion is that P is true. However, this is invalid because P might be true given those first 2 premises, or P might be false. So those 2 premises don't lock in and guarantee that the P portion of our syllogism, our conditional syllogism, is going to be true. So let's put some context to this. Premise number 1, if you study, then you will get a good grade. Premise number 2, you get a good grade. We want to conclude as human beings, you know what? You must have studied. If you study, then you'll get a good grade. Here you are with a good grade. You must have studied. And as we saw last lecture, that's not the case. Because even if the rule is, if you study, you will get a good grade, just because you got a good grade does not mean that you studied. Because you might have studied, that's one possibility why you got a good grade, but you might have done something else. like you might have cheated and copied off of somebody that did study. So both of those ways could guarantee that you got a good grade. By the way, I mentioned it before, don't cheat off of other people. Both of those ways could have gotten you a good grade. So you'll notice that just the fact that you got a good grade does not lock in guaranteed that you studied. You might have done something else, and that's what makes this an invalid argument. We cannot conclude that P is true because P might be true, but P also might be false. All right, and then the other invalid conditional argument is called denying the antecedent. Once again, no fancy Latin name. Once again, this is going to be premise number 2. So premise number 1, if P then Q. For premise number 2, we're going to deny the antecedent. So we're going to say that P is false. So if premise number 1 is true and premise number 2 is true, then we would like to conclude, we might be tempted to conclude that Q has to be false as well. But this is an error. This is an invalid argument because Q might be false, but Q also might be true. Given those first two premises, Q could go either way. So premise number 1, let's put some context on this. Premise number 1, if you study, then you will get a good grade. Premise number 2, you did not study. The conclusion, what we would like to conclude, what we're tempted, you will not get a good grade. However, this conclusion is not guaranteed because even if the rule is if you study, then you will get a good grade, and you did not study, that does not guarantee that you will get a poor grade because the rule is if you study, you will get a good grade. It says nothing about if you don't study because you might not study and end up with a good grade. Again, if you got that good grade by other possibly nefarious means. So because those two possibilities still exist, given those first two premises, concluding that you must have not studied is not valid because it's not locked in, it's not guaranteed. All right, so in terms of the conditional syllogisms, if we were logical, if we reasoned the way we're supposed to, according to logic, then we should accept arguments that are affirming the antecedent. So that three-step argument, if P then Q, P is true, therefore Q is true, we should accept that one. We should accept denying the consequent. We should reason that way. So we should accept the if P then Q, Q is false, therefore P is false. We should accept those arguments. And we should not accept, we should call people out on this. We should not accept the conclusions that come from affirming the consequent because that's an invalid argument, nor should we accept the conclusions from denying the antecedent because that's also an invalid argument. So that's what we should be doing. We should accept the valid arguments. We should reject those invalid arguments. We shouldn't think that way. Descriptive reasoning. How do we actually reason? Well, this is where the psychologists come in with their experiments, and this is where we're going to turn to Coglab number 12. So Coglab number 12, this was all about the conditional syllogisms. This was all about testing your affirming the antecedent, denying the consequent, affirming the consequent, denying the antecedent. Which one of those do we accept? So the way that this was set up was on each trial, you were given a rule and you were shown 4 cards. And your task was to pick 2 cards to decide if that rule was being violated. So you would see a display like this, and it would give you a conditional syllogism. It would give you that first premise. If a card has a vowel on one side, it must have an even number on the other side. It would have a bunch of selections. Those 4 selections, F, 4, 7, and E, those represent the 4 second possible premises. So those are the 4 premises that can make up the second premise of these conditional syllogisms. And then if you flip it, what you found on the other side would be your conclusion. All right, so that's one way of thinking about this to tie it back into what we've been looking at so far. Now, there was another added wrinkle to this, which was the independent variable, and that was the type of rule. Whether the rule was an abstract rule or whether the rule was a thematic rule. So the abstract rule was where you could not use your knowledge of the world to try to answer the rule or to try to analyze the rule. So the rule had no context that you could bring to the situation, things that you could use from your previous experience. On the other hand, the thematic rules did have that context. They did have knowledge of the world that you could bring in to help you answer that situation. So we've sort of experienced these so far in today's lecture. So an abstract rule would be something like if P, then Q. A thematic rule would be something like if you study, then you will get a good grade. If P, then Q, you can't really use your experience from your life to help you answer that. But if you study, then you will get a good grade, you can use knowledge because hopefully somewhere along the line you have studied and you have gotten a good grade. All right, so the dependent variable on this was the mean number of correct cards that you chose in order to test the rules. So this was out of 2. If you were perfect on this, if you were a normative reasoning machine, then you knew exactly what to do, you would get 2 out of 2. If you made a mistake, made 1 mistake, you would get 1 out of 2. If you made 2 mistakes, you would get 0 out of 2. So you could go anywhere from 0 all the way up to 2 out of 2. And you were tested on abstract rules, such as this one right here. So if a card is textured on one side, it must have a cow on the other. You probably don't have a long history of working with textures and cows, right? You probably don't have a long history of, I don't even know how to describe a world where this exists, where you had a job somewhere where you had to test the texture on one side and the cow on the other. So this is an abstract rule. It doesn't really bring in any sort of real world experience. And now you have to decide, which cards do I flip over? Do I flip over the textured card, the cow card, the goat card to see what's on the other side, or the smooth card to see what's on the other side? But importantly for our purposes now, this was an abstract rule. Another example of an abstract rule, if a card has salt on one side, it must be pink on the other. You've probably, again, never encountered a situation where it was important to determine if pink and salt were going together, right? That's not something that typically happens. And then this is the classic one that was used in the original Wason selection task. If a card has a vowel on one side, it must have an even number on the other. So it is probable, it is very probable that nobody in the history of your lifetime has ever come up to you and said, you know what, I'm throwing a party tonight, and I'm a little worried that vowels and even numbers are not going to, they're going to not be following their rules. I'm a little worried that these vowels and even numbers are not going to stay together. So I really need you in this party that I'm throwing, because I don't want to get arrested. I need you to make sure that if a card has a vowel on one side, make sure that it has an even number on the other side. Can you do that for me? You have probably never encountered that situation. That's what makes this an abstract rule. However, you have probably encountered this situation. So you have probably encountered a situation where if a person is drinking beer, that person must be 21 years or older. You might have thrown a party where you had to make sure, as a responsible party thrower, that if a person is drinking beer, that person is 21 years or older. You might have been the person that was under 21 yourself, very aware of this rule, that if you get caught drinking beer, that's not going to be okay. So whatever the context was, this was the thematic rule because you could bring real world experience to this rule. And we're going to see if this helps make it easier to reason about how to correctly solve this conditional syllogism, because it still is a conditional syllogism. It's still an if P then Q statement. It's just that now we can bring on our previous experience. All right, thematic rule number 2 example. If you ride your bike after dark, you must wear reflective clothing. This is something that I can easily draw on my own life or personal experience, because I do ride my bike after dark, especially in the fall months when I'm working at IUSB and I commute home on my bike and it's late at night and the sun has gone down, and I do wear reflective clothing. So that's something that I can bring my own personal experience to. And then I am sure, after discussing this with many students who have jobs, this is another important rule that you probably have personal experience with. If you work overtime, you must be paid extra. So the question here is, when do you need to check this? Do you need to check your paycheck if you've worked overtime? Do you need to check your paycheck if you haven't been paid? Sorry, do you need to check your hours if you haven't been paid extra? Or do you need to check it when you haven't worked overtime or when you were paid extra? Which ones do you need to flip to make sure that you got paid for the work that you did? All right, so those are the situations. Let's take a look at the results. So here we have, on the x-axis there, we have the type of question that it was being asked, or the type of syllogism. Was it an abstract syllogism, or was it a thematic syllogism? Abstract, can't use world experience. Thematic, you could use world experience. And then on the left side there, we have the mean number of cards correct. And basically, the higher the bar goes, the more correct answers, the more correct cards you chose. So the first thing to notice is that this does not go all the way up to 2. 2 out of 2 would be perfect performance. So on average, we humans don't have perfect performance. So we're not going to make it to that normative reasoning goal. We're not going to make it to that normative reasoning ideal. On the other hand, you'll notice that the average is above 1. So typically, we at least get 1 card right. So at least we're doing something correct. So let's first take a look at what is the effect of having that world experience? What is the effect of being able to bring in that world experience? Because logically, world experience should do nothing. Logically, world experience does not impact reasoning through a conditional syllogism. Because if P then Q, P is true, Q is true, that's all you need to know. That's what a logical reasoning argument is, for example. So world knowledge, putting world knowledge on that really shouldn't help. Normatively, it shouldn't help. However, as we see, the correct number of cards turned over in the abstract conditions is less than the correct number of cards turned over in the thematic condition. So here we have our first descriptive reasoning discovery, which is that help from knowledge of the world actually helps you reason. So your previous experience, your familiarity with the world, that actually bizarrely, counterintuitively, why would it ever, but it does, that actually helps you reason about the conditional syllogisms that you encounter. All right, so that was one of the conclusions. What we're going to do now is we're also going to take a look at not just that the thematic information helps, but what kind of errors do we make? So what cards should we check according to normative reasoning? If asked, if P, then Q. We're going to take a look at that. And then we're going to take a look at, does this actually violate normative reasoning? So is there a difference between normative reasoning and descriptive reasoning for this task? So I'm going to answer that question right off the bat, and the answer is yes. And we've already seen this because if our normative reasoning was the same as, if our descriptive reasoning was the same as normative reasoning, both of those bars that we just saw should be 2 out of 2. If you are a logical machine and you could solve this perfectly every single time, the abstract bar and the thematic bar should both be 2 out of 2. The fact that they're not, the fact that they're less than 2 out of 2 means that there has to be a difference between what we did and what we should have done. That is, there has to be a difference between the descriptive reasoning and the normative reasoning. So now it's our job as psychologists to shine some light on what that difference actually is. All right, so let's return back to the Wason selection task, the classic rule. If a card has a vowel on one side, then it is blue on the other side. And this was, again, the premise number 1. And then what we have here is we have our 4 possible premise number 2s. So we have a card with a vowel on one side. That is affirming the antecedent. We have a card with a consonant on one side. That is denying the antecedent. We have a card that is blue on one side. That is affirming the consequent. We have a card that is red on one side. That is denying the consequent. So what should we flip logically now that we've kind of labeled it in that way? Well, let's take a look at one of the ones that we should flip. So if a card has a vowel on one side, then it is blue on the other side. One of the ones we want to do is we want to affirm the antecedent. Means that we choose as premise number 2, the card has a vowel on one side. Because if we take a look at this card and we flip it and there's blue on the other side, that means that the rule has been followed. So that is a good thing to know. More importantly, though, is that if we flip it and it turns out to be not blue on the other side, we know that the rule has been violated. So we know that those 2 premises lock in the conclusion that the card has to be blue on the other side. So if we find out that it is not blue on the other side, we can conclude that the rule has been violated, and that is because this is a valid argument. This is affirming the antecedent. So this is the first one that we should flip. We should flip the A card. More importantly, we should flip the P is true card, affirming the antecedent. What else should we do logically? Well, we've taken a look at affirming the antecedent. The other valid conditional syllogism is denying the consequent. So in this case, the consequent is it is blue on the other side. So we should flip over the card that is not blue on the other side. So we should take a look at the red card. Because if we flip over that red card and it's a consonant, that's fine. This rule says nothing about consonant cards. It says nothing about cards that have a consonant on one side. But if we flip over that card and there's a vowel on the other side, that's a violation. Because if it got a vowel on one side, it has to be blue on the other. So those two premises that we have guarantee that the card does not have a vowel on the other side. So if we flip it and find a vowel on the other side, well, then we find a violation of the rule, and this is the valid argument denying the consequent. So those are the two things that we should do. What about the things that we shouldn't do? Well, the first one that we shouldn't do, we're going to take a look at. This is affirming the consequent. So if a card has a vowel on one side, then it is blue on the other side. The card is blue on one side. So this is premise number 2. And remember that this is an invalid argument, because if we have blue on one side and we flip it over and the other side is a vowel, that's fine, right? That's within the laws of the rule. However, let's say that we flip over the card and we find out that it's a consonant. That's also fine, because this rule does not apply to consonants. It doesn't say that only vowels can have blue on the other side. So it gives us no evidence either way of whether the rule has been followed. And this is why the conclusion that the card has a vowel on the other side isn't locked in, because this is affirming the consequent. This is an invalid argument. So given the truth of the first two premises, that if it's a card that has a vowel on one side, then it's blue on the other side, and the card is blue on one side, that does not lock in the requirement that the card has a vowel on one side, because it could have a vowel on one side or it could have a consonant on one side. Doesn't really matter. So this is an error. Flipping over the blue card, flipping over the Q card is an error in this situation. And the other error that we have is that we flip over the not P card. So we have, if a card has a vowel on one side, then it is blue on the other side. We flip over the card that does not have a vowel on one side. And again, these two premises do not guarantee a conclusion. Because if we flip that card over and it has a red backing, that's no evidence, because the rule is about vowels and blue cards. So if we flip it over and it has a blue card, that's also no evidence, because that rule is not about consonants. It's about vowels. So our human minds might want to conclude that given that the card does not have a vowel on one side, then it's not going to be blue on the other side. But in reality, logically, it could be blue on the other side. It could be red on the other side. Either one is possible. Neither one is locked in by the premises, because this is the invalid argument of denying the antecedent. So for the conditional in general, for the conditional if P then Q, what we should check is we should check P and see whether or not it has Q on the other side, and that is affirming the antecedent. That's doing the second premise of the affirming the antecedent valid argument. And we should also check not Q. Q is false. And that is the denying the consequent second premise in this particular example. So that is the denying the consequent. That's the only other valid argument. So those are the two that we should choose. We should choose P and we should choose not Q. So if we take a look at our abstract rules, if a card is textured on one side, that is your P statement. So we should check P if we were going to do this correctly. We should check the textured card and make sure that it has a cow on the other side. Now, cow on the other side is the Q portion of this statement. And according to valid conditional arguments, we shouldn't check Q. That's the mistake. we should check not Q. So we don't check the cow. We don't flip the cow over to see what's on the other side because that will tell us nothing. What we need to do is we need to flip over the goat. And we need to make sure that it is not textured on the other side. Because if it's textured on one side, it better be a cow on the other, not a goat. So we flip over the goat because the goat is not Q. It's not a cow. If a card has salt on one side, it must be pink on the other. Salt on one side, that is the P portion of this syllogism. So we would correctly flip over salt on one side, make sure that it's got pink on the other. Pink on the other is the Q portion, so we want to deny the consequent, and we want to flip over not pink. And in this case, that would be purple, making sure that it does not have salt on the other side. And then we'll continue on with this. Hopefully you can see that once you kind of know the rule, it becomes a lot more simple. So if a card has a vowel on one side, it must have an even number on the other. Vowel on one side, that's the P portion. So we're going to want to flip over E. Even number on the other side, that is the Q portion. So we don't want to fall for the trap of flipping over that 4. We don't want to affirm the consequent because that's an invalid argument. We want to deny the consequent. We want to flip over the not even number, the odd number 7, and then see if we see what's on the other side, making sure that it's not a vowel. So those are the abstract rules. And then on the thematic rules, you can see that it kind of gets a little bit easier. Because for this one in particular, if a person is drinking beer, that person must be 21 years or older. We just kind of immediately know that the people we need to check at a party who are, in order to follow this rule, are the people that are drinking beer and the people that are underaged, right? So the people that are affirming the antecedent, they are drinking beer. So we got to check the IDs of everybody that's drinking beer. And we have to check everybody that is not 21 years or older. We have to check, for example, the 16-year-olds to make sure that what's in their cup is not beer, right? So it's a little bit easier to do that, check your P and check your not Qs in this case, because we can bring our knowledge of the external world. We can bring that context. And again, that shouldn't make a difference. To a logician, that makes no difference, but to a real thinking human mind, it does. And that's what we're here to understand. How do we actually reason? So once again, if you ride your bicycle after dark, you must wear reflective clothing. Ride your bicycle after dark, that's the P portion. So if we wanted to enforce this rule, we would have to check everybody that rides their bike after dark. And if you're wearing reflective clothing, that's fine. Ride in the night, ride in the day. Tells us nothing. The people we need to check are the people that are not doing this. The people that are not wearing reflective clothing, to make sure that they are not going out on their bikes after dark. And then finally, if you work overtime, you must be paid extra. This is probably really easy for most of us because we've all put in our overtime hours. I know some of you are putting in extra overtime hours now due to this coronavirus. But again, in this case, if you work overtime, you need to check your paycheck. So if you worked overtime that week, you want to flip that over and make sure that you got paid extra. And then if you check your paycheck and you see that you've gotten paid extra, you don't need to check whether you worked overtime, right? Just take the money and go. Like bank error in your favor, that's great. But you need to check if you were not paid extra, because you better be sure that that was not a week where you worked overtime, right? So that's what you need to check. You need to check the not Q, not paid extra. So that's what we should do for the conditional syllogisms. We should check P and we should check not Q. What do we actually do? Well, as it turns out, we actually do check P. We actually do affirm the antecedent. That was the one that we typically got correct. The error that we typically make, however, is we also check Q. That's the error that we typically fall for. We fall for the invalid argument of affirming the consequent. So in this, if it has a vowel on one side, it has to be blue on the other. We tend to fall for the trap of checking the blue card. And again, that gives us no evidence, because if we flip it over, regardless of what's on the other side, it doesn't matter. It gives us no evidence whether the argument has been followed, because this is an invalid argument. K or E is not locked in either way. So this is what we should do. These are the choices we should make. Flip the E and flip the 7, flip the vowel and flip the not even number. What our human minds tend to do is flip the vowel and flip the even number. Look at P and then incorrectly look at Q. So this is what we should be doing. Check the work overtime card and the not paid extra card. This is what we sometimes will fall for. Check the work overtime card and check the paid extra card. And again, that paid extra one, that is affirming the consequent. That's an invalid argument. So for descriptive reasoning, under thematic conditions, what do we accept? Well, we typically do affirm the antecedent, and we are actually better at denying the consequent. We're actually better at doing that correct, valid argument of denying the consequent. And what we do not accept is we do not accept affirming the consequent, and we do not accept denying the antecedent. So under thematic conditions, we check the people drinking beer, and we check the people that are 16 years old, right? We affirm the antecedent, and we deny the consequent. We do much better under thematic conditions, much more like normative reasoning. Put us in abstract conditions, and our human minds fail. So we will accept affirming the antecedent, but we will incorrectly accept affirming the consequent. We'll look at that Q card and flip it over looking for P, not realizing that it tells us nothing. What do we not accept? We don't accept denying the antecedent. That's right. That's an invalid argument. We shouldn't. However, we also don't accept denying the consequent, and that's the big difference between descriptive reasoning and normative reasoning for conditional syllogisms. So as cognitive psychologists, we would now ask ourselves, why? What's going on here? What are the representations that we use that are leading to this errors? That's beyond the scope of this course, but that is what the next step would be. Now that we've identified what we do, descriptive reasoning, we then go to the representational stage of understanding, try to figure out why we actually do it. All right, so that is it for today's look at reasoning. Next time that we meet, we're going to continue on with Chapter 13, and we're going to take a look at decisions. We're going to take a look at the Pirate Booty Challenge, which is a fun way of trying to figure out whether or not you'd be a good pirate captain and how much you can get away with. So all that and more next time that we meet, but that's it for today. So thank you so much for joining me. Keep yourself safe, and I will see you all next time.